Today's activity is a retirement problem. This is just an extension of equating annuities that we did in the prior lecture. And it's one of our more advanced time value money problems again. The idea here will be the same as our car problem. We're going to set one side of the problem equal to the other. And the way we're going to do that is we're going to think about how a retirement problem works. When you save for retirement, you're saving for the future. And just like the idea from last time, if I'm saving for the future, I'm moving money into the future. So I'm finding a future value. When we think about what happens when we retire, we start spending money. So money goes out of our account. So often what we want to know is how much money do we need to retire? Well, we basically need enough to support all the withdrawals that we make. So one way to think about retiring is you're almost taking a loan out on yourself. You're making withdrawals off a balance that you accrue the day you retire. Now this is a little different from the car problem. With the car problem we just added up the two parts of our answer together and got the car price. Here we just need to use a little common sense and think about what happens when you retire. We can only spend what we've saved. So the future value of our savings has to equal what we can withdraw. So in other words, the future value of our savings will equal the present value of our withdrawals. Now we've sort of gone through this process already, but basically we're going to move money into the future, find what the value is, and that's the money we're going to spend. So hit pause and read through this example. So essentially we're going to retire in 40 years. So that means we can contribute 40 years worth of money or part of our salary for our future retirement benefits. When we retire, we think we're going to live 20 more years and we want to spend $100,000 per year. Now in reality this is the best guess we can make, in life, and with the advances in healthcare this number keeps getting bigger. So when you think about this on your own personal level, you may want to do more than 20 years. Okay. Well, let's assume all our money stays in the account at 9%. So that just tells you that when you do retire, you don't just pull the money out and put it under your mattress. You keep it invested earning 9%. That allows you need less when you retire when you keep earning interest on your money. All right, here's the solution. Well, when we solve this, we always look at what information do we have. Well, if you looked at the problem, we know what we want to do in retirement. We know we want to spend $100,000 per year. And we know it's going to be 20 years. So our first step is let's solve what we have. We know what retirement is going to look like. So our first goal is let's find how much money I need the day I retire, which will just be the present value of those 20 years of $100,000 withdrawals. Now the only trick here is that when you spend money out of a retirement account, you have to have it to live on immediately. So your first withdrawal is typically at the beginning of the year. So this makes this an annuity due. So to find the present value of my retirement withdrawals, we just apply the present value of an annuity due formula. We recognize that the payment's $100,000. Our account earns 9% per year, so the payment and the interest rate match. They're both on a yearly basis. And then 20 is the length or the number of withdrawals that we're going to make. So here's our by hand formula. Keep in mind on a calculator we need to set it to begin. We plug in 20 years, 9% interest, $100,000 payment, compute the present value. So we only require $995,011.48. Now I put the Excel formula in below just to show you how you could do this if you wanted to do it on a spreadsheet. So to finish this problem, we now know we need almost $1 million the day we retire. So my savings has to reach that amount. So to solve for the savings, we just recognize that it's an annuity. We're going to make yearly contributions for 40 years. It'll earn 9% a year, and they have to reach a future value of $995,011. Plug it into the calculator. We get in as 40, I is 9, present value is 0, future value $995,011, and compute the payment, which is $2,944. Key point here, make sure you switch your calculator back to end before you solve this savings portion, because most people contribute at the end of the period. Now this is our last example for time value of money. And these problems can get fairly hard. The key is just repetition. So work some of the assigned problems that I've given you, master them, and you'll do well on test day.